Yo, what's up? Welcome back to another video. Since I basically did stack and queues, I will be able to pretty much do some questions, I guess, LeetCode problems, whatever. So for example, like this one, right? Also, I'm back from my little vacation, so I can do some LeetCode now and then make more videos afterward. But anyway, so let's same things, usuals. I'm gonna read the prompt, write out the code, and I'm gonna explain it. I guess kind of line by line. Anyway, so 225 implement stack using queues. Implement a last in first out LIFO stack using only 2 queues. The implemented stack should support all the functions of a normal stack. So push, top, pop, and empty. What we have is implement the myStack class. So we have push, which pushes the element X to the top of the stack. Pop removes the element on the top of the stack and returns it. Top just shows the top of the deck. And then empty is just going to return true or false based if the stack is empty or not, you know? Okay, so let's see. So here's the examples, kind of. There's only one. And then let's see notes. You must use only standard operations of a queue, which means that only push to back, peep/pop from front, size, and is empty operations are valid. Depending on your language, the queue may not be supported natively. You may simulate a queue using a list or dequeue as long as you only use a queue standard operation. Very simple, because, okay, so what we do is, it's kind of like how I did it with, like, my videos, except I'm just using, I'm going to be using queue and linked list. Okay, so, alright, let's see. From how I would do it, or the idea of it is, we want a stack, right? So, but we're only allowed to use, like, the queue operations. So the stack is last in, first out. Queue operation is first in, first out. And we're going to be using 2 queues, so I'm just going to call it Q1 and Q2. And make sure the front of Q1 is always the top of the stack. And I'll explain, like, my process as we're going through. So first, import Java. Import Q. Another. I'm going to import linked list. There we go. So inside here, I want to create my queue, which is in this integer. We're going to call it Q1. And we're going to create another one. We're going to call it Q2. Oh, oops. They shouldn't be in my stack. They should be outside. Sorry. They should be around here. There we go. Much better. Now, inside my stack, I want where Q1 is basically a new linked list. Oops. Wrong way. And Q2, same thing. Did I spell it wrong or something? Oh, that's right. There. Oh. Wait. Right. There we go. Okay, good. All right, so there's that. That's it for my stack. Now push. Actually, how about before push, let's do the easier ones. Push has a little bit more into it, and I'll explain as I want. But the empty is very simple. You just return Q1 with the is empty operation. So there's that. Top. So for top, we just return again Q1.peak. And then for pop, it'll be return Q1.pull. Now pull is pop, basically. Okay, so now we're doing push. So step 1 will be, we're going to push new elements into Q2. So Q2 offer, and offer is basically like you're pushing it, you know, the integer X into Q2. Now we're going to do while Q1 is not empty. Then Q2 offer Q1.poll. Then there's that. And then step 3, we'll have Q integer temp equals Q1. And then Q1 equals Q2. And then Q2 equals temp. So this is, down here would be like the swap. You're swapping Q1 and Q2. So swap Q1 and Q2. Right here, this step over here is sort of like you move everything from Q1 into Q2, as long as Q1 is not empty. So move everything from Q1 into Q2. And then obviously the very first step would be push new element into Q2. So there's that. Okay, so let's first test it out actually. Make sure there isn't any error. And it seems like there is. There we go. Anything else? No. Okay, seems like it's good now. All right, so I'll basically explain how the push works. So you the goal of like, so like you're gonna be questioning, why is push, like why is there so many more things in push? Our goal is we want to pretend we have a stack, right? But we're only allowed the Q operation. So what Q can do is it can push to the back, which is NQ, and then remove from the front, so DQ, and look at front, right? Stack needs push, pop, peek at the top, like last in, first out, basically. So we're in order to sort of like maintain, or we're trying to maintain the solution by like having it the front of Q1 should always be the top of the stack. So I'll give an example too. Now I'll write it in comment here. So let's say I call push 1 and then push 2 and push 3, right? So when I call the push, it's basically we're like we want the front of Q1 to be 3, since 3 is the last push, okay? Because so like the stack top equals the last, whatever is the last push. So I'll walk through how it's gonna work. So first things first, we're gonna assume Q's like show front on the left, and that's all. And so at the start of at the very beginning, it's gonna be like an empty stack. So Q1 is basically empty. Q2 is also empty. Now when you do the first one, which is push 1, what it's gonna do is we're gonna first do Q2.offer, and offer basically makes it where like the Q2 will like add the 1 into it, right? You're putting the 1 into Q2. Now you want to do move everything from Q1 to Q2. However, this while statement wouldn't work because Q1 is currently empty. So we skip this part. Now that we skipped, we can do the third step, which is swapping Q1 and Q2. And when that happens, it's just a typical temp Q1 and Q2, thing. So when that happens, Q2 no longer has anything, but Q1 has a 1. So now the 1 is there for the Q1. And now let's try it. Now we move on to push 2, right? So push 2, again, we push the new element into Q2. So 2 should be in here. Now move everything from Q1 into Q2. This time, the while statement is true. It works because Q1 is currently not empty. So again, we're gonna remove 1 and add the number, like we remove Q1, the number in Q1, and then add Q2 into it. So what's gonna happen now is the 1's gonna be gone and then be added up here. So when that happens, now 2 is at the front and 1 is behind it. And once again, now we go back all the way to step 3 where we swap Q1 and Q2. So now Q1 is all empty and Q2 is all empty. Now Q1 has the 2 and the 1. So again, like I kind of showed you, like I mentioned, we want to assume that the left is basically the top of the stack. So now 2 is indeed on top of the stack. Now we push 3. When we push 3, again, same thing. Q2, we push the new element into Q2. So now Q2 has 3. While Q1 is not empty, which is true, we remove Q1 and add it up to Q2. So what's going to happen is we're going to first remove the 2 and then add up here. And again, the while statement is still true, so we do the same thing with 1, and that's it. Now Q1 is empty, so the while statement is no longer true. We move to step 3, which is we're swapping Q1 and Q2. So now we basically go all the way up here and start adding it like this. And now the front of the Q1 is 3, which also means that it is on top of the stack. And that is basically it. So, and I pretty much explained it as well, and it worked. I'm just going to run it again just to make sure I didn't accidentally press anything weird. And let's submit it. Perfect. So all the test cases passed. And yeah, now I'll just make a quick, comment about the time and space complexity. So here's time, here's space. Okay, so with time, the empty, top, and pop, they are all big O of 1. Because all they have is just one operation. That's it. You just do one thing, and that's it. Now, the push is interesting. Push is big O of n because we're moving all elements from Q1 to Q2. So that's why it's big O of n. And then for space complexity, it is also big O of n. For storing the elements into the queues. That's why it's big O of n. And yeah, I think that's it. So pretty simple, not that bad. Yeah, thanks for watching.